This is 0.1 ampere. Clear all of you? Okay. I of 0 minus is 0.1 ampere. Since I is the current through the inductor, I of 0 plus is also equal to what? I of 0 minus. That's it. Okay. Now this problem is over. But there is a second one, this particular one. Higher order derivative term. Yes or no, all of you, di by dt. Okay. First order derivative term. First order derivative term. di by dt at t equal to 0 plus. When first order derivative term is asked, immediately you have to check once for safe side whether this I is current through inductor or not. Yes, I is current through inductor. We can determine easily. Okay. So without step 2, let's go for step. Without step 3, let's go for step 2 only. Step 2, to construct T equal to 0 plus equivalent circuit in step 2, what do you need basically? You need IL of 0 minus and VC of 0 minus. Can you tell me what is VC of 0 minus? 0, because it is not getting charged. What is IL of 0 minus? How much? 0.1 ampere. Yes or no, all of you? 0.1 ampere. So let us use this information in constructing T equal to 0 plus equivalent, and let's see what will happen here. Now this capacitor is replaced by, what is the equivalent of the capacitor when voltage across the capacitor is 0 at T equal to 0 minus? It is equivalent to short circuit. Remember all of you, this is B, and now the resistor remains resistor. The inductor is replaced by a current source with a parallel inductor model. Remember all of you? Parallel inductor model. Now what is your objective here? You know that di of 0 plus by dt is VL of 0 plus by L. That means you require voltage across the inductor. Where is the inductor? This is the inductor. So can I say this is VL of 0 plus? You can ask me, sir, how do you know the polarities? Yes, I know the polarities because based on the direction of current. Current is flowing in downward. This is a passive convention says that this is VL of T. Then I am taking what VL of 0 plus because it is at T equal to 0 plus. VL of 0 plus, that's it. Now what is the current actually here? 0.1 ampere. What is the resistance value? 1000 ohm. R is equal to. Okay. Now what is VL of 0 plus? This is minus. This is plus, right? But the current flowing here, it is what it's creating. This is plus, this is minus. Okay. This value is 0.1 into 1000 ohm. Yes or no, all of you? Okay. What is this actually? 100. And polarities are plus minus. But how you want the polarities? See, the polarities because of the current direction is plus minus. But how you want the polarities? You want to measure this is plus, this is minus. That means this is minus, opposite polarities. Therefore, the desired polarities and actual polarities are exactly opposite. Therefore, VL of 0 plus will be minus 100 volts. Minus 100 volts. Now you can substitute here. Therefore, di of 0 plus by dt will be giving you minus 100 by, this is a L value 1 Henry, that is amperes per second. Please note down. This is how you are supposed to do the problems, okay? This is very, very important observation. The first order derivative terms. Never go for step 3, but also practice the problems using step 3 because we do not know tomorrow the problems may come in any direction. Clear all of you? I think you have solved this. Okay. So I think all of you understand this problem, right? It's very clear. I di by dt. When first order derivative term is asked, check once whether this I is the current through inductor or not. Sometimes he will give V. You have to check whether that V is the voltage across the capacitor or not. Okay, definitely 99.9% the problems will come. Okay, I current through inductor, V voltage across capacitor basis only. Okay, if that is the case, then go for step 2, not step 3. Okay, that's very, very important. You can save a lot of time. Now, let's go for another problem. Question number 6. Question number 6. Classroom workbook, question number 6. Find Vk and dVk by dt at t equal to 0 plus. Okay. The C value is given 1 by 2 farad. L value is given 1 Henry. R value is given 1 ohm. And this is 2 volts voltage value. What is he asking actually here? Vk and dVk by dt at t equal to 0 plus. At t equal to 0 plus. Okay. Now again the derivative term. Whenever there is a derivative term, usually it will be first order. But anyway, you have to check once. Okay. And first order derivative terms are given in the problem. Then you check whether that voltage Vk, dVk, Vk is the voltage across capacitor or not. Vk is nothing but voltage across the switch, but already capacitor is also placed across the switch. Therefore, it is a voltage across capacitor. Okay. So whenever voltage across the capacitor is given, okay, dVk by dt can be determined from what? Step 2. There is no need to go for step 3. And Vk is the voltage across capacitor that you can get from step 1. Yes or no? Okay. So do it all of you. Step 1, start. Start doing the problem. Start doing the problem, all of you. Step 1. What is step 1? Construct T equal to 0 minus equivalent and find IL of 0 minus and VC of 0 minus. Understand all of you? Okay. So let's do that. Let's do that. What is the switch position? Close. Because you're opening at T equal to 0. At T equal to 0 minus, it is closed condition. Therefore, so the capacitor is acting like open. Inductor is acting like short circuit. Resistor remain resistor. Okay. Your objective is to find the VC of 0 minus, IL of 0 minus. Because first step is always dealing with what? IL of 0 minus and VC of 0 minus. Since it is across short circuit, you cannot charge the capacitor keeping a short circuit across it. 0. Now this is current flowing through resistor R, and now you have directly this current is passing like this. So what is that? IL of 0 minus is, okay, that voltage source by resistor. Now 2 volts by 1 ohm ampere. Clear? Now, what is he asking? Let us see. Okay, first your focus must be like this. Whatever the problem it might be, irrespective of the problem statement is given, the first step is always deals with current through inductor, voltage across capacitor. Now you look at the question. What is that? Vk. What is Vk? Vc. Vc at t equal to 0 plus. Nothing but Vk of 0 plus is nothing but what? Vc of 0 plus, nothing but Vc of 0 minus is nothing but 0. That's it. Okay. So first the question is solved. Now let's look at the second one. The first order derivative term, whenever it is asked, I told you already that go for step 2. Understand? Construct t equal to 0 plus equivalent. Now to construct this t equal to 0 plus equivalent, let us make use of the values that we obtained, Vc of 0 minus and IL of 0 minus. This entire circuit depends on these two values only. Okay, so I'm just taking the voltage source and capacitor. Now here the switch is open, right? Okay, the switch is open. Capacitor is acting like what? Voltage 0, nothing but short circuit. The equivalent of the capacitor T equal to 0 plus is short because the voltage across capacitor was 0 at T equal to 0 minus. And what about this one? Inductor, current source with a parallel inductor model. This is the resistor. Yes or no, all of you? Okay. Now, this is an inductor and this is 2 ampere. This is actually 1 ohm, right? How much here? 2 volts. And what is he asking actually here? dVk of 0 plus by dt. In fact, dVk of 0 plus by dt, okay, is nothing but C only, right? Therefore, IC of 0 plus by C, yes or no? But what is IC actually here? This is what the current, right? IC of 0 plus. IC of 0 plus and these 2 amperes both are same. Therefore, 2 amperes in this context, because look at this path, same path, right? So therefore 2 amperes and C value is 1 by 2. Therefore 4 volts per second. Understand all of you? Okay. dVc of 0 plus and dVk of 0 plus both are same. It's nothing but, okay, these two are same, right? Okay, nothing but what? IC of 0 plus by C we can find. So very simple. But one must be good at solving the networks, I'm telling you. If you're not good at network solving, you cannot really solve the problems, okay? That is why I started first DC circuits and discussed elaboratedly how to solve a given network. Hope I think by this time you got command over solving the networks. You note down that. Meanwhile, I just note another problem. Question number 7. Okay. This is an interesting problem. Find VA of 0 plus. Find VA of 0 plus. I think you have done right. Okay. Look at that problem. Question number 7 is asking VA of 0 plus. What is VA? Whenever the problem is given, first you define what is that voltage or current, whether it is related to inductor or capacitor or resistor. Okay. From that itself, you can understand whether step 1 is required. Of course, step 1 is always required. Whether we need to go for step 2 or not, step 3 or not, all these things you can come to know easily. Okay. Now, step one. What is actually VA of 0 plus? I mean VA is definitely not voltage across capacitor. Other than voltage across capacitor, definitely you have to go for step 2. Agree all of you? Then step 1 first. Whatever the problem it might be, first you have to go for step 1. Construct T equal to 0 minus. How does it look like? Switch open. Capacitor is acting like open. Okay. Now this is open, right? Okay. Already the switch is open condition. You are closing the switch at T equal to 0. Therefore, it is open. This is the capacitor physically available. But in the first step, always you are dealing with voltage across capacitor. You don't need any other information here, right? Okay. Therefore, VC of 0 minus, you need this information. Okay, he might be asking the VA of 0 plus here, but I don't want to find VA of 0 minus. It is useless to find that value. Yes or no, all of you? But I want the voltage across the capacitor. Okay, since it is open circuit, there is no written path. Here also there is no written path. Then you can't expect any current through these elements. Okay, if this is 5 volts, if this is 0, this is what? 5 volts. Do you expect any current in this one? No. Therefore, here also it is 5 volts. Do you expect any current in this here? No. Therefore, the drop is 0. Here also it is 5 volts. So finally, VC of 0 minus is how much? 5 volts. Getting all of you? Okay. Now, we use that information when we construct T equal to 0 plus equivalent. Understand all of you? Okay. Now, step 2. Let us use that information in step 2. Construct T equal to 0 plus equivalent. Construct T equal to 0 plus equivalent. Okay. Switch closed. Now, the capacitor is replaced by what? Voltage source with a series capacitor model. Yes or no? Yes or no? This is 5 volts. 10 ohm, 10 ohm, 20 ohm. What about this? 10 ohm. You understand? Okay. Now, what do you want actually here? 0. This is VA. But since it is at T equal to 0 plus, I can say VA of 0 plus. This is 5 volts. Okay. This is 5 volts. 5 volts. Right. Now, let us find that VA of 0 plus. Now, it is as good as solving a simple network. Probably you can use node analysis because it is 0. This is already, it doesn't have any resistor, therefore it is 5 volts. It doesn't have any resistor, it is also 5 volts. So I think you can easily find. Okay. VA of 0 plus. I'm using inspection, okay. 1 by 10, 1 by 20, 1 by 10 is equal to 5 by 20, 5 by 10. That's it. Solve this. VA of 0 plus, you will get 3 volts is the answer. You calculate it, I'm sure that you will be getting 3 volts. Let me check once. The answer, yeah, is supposed to be 3 volts. Okay. So your observation is very, very important in each and every problem. I'm just taking different varieties here, okay. Understand? Question number 7 is over, and question number 8. I'm just noting down the problem. Meanwhile, you please complete that. Same problem with the capacitor replaced by an inductor. Let us see what will happen. Capacitor replaced by inductor. 2 Henry. Everything same. Yes. Question number 8. Same problem. VA of 0 plus. Question number 8. VA of 0 plus. Okay. So how do you solve it? Let me take this off. I think you have finished this. Okay. Again, the same procedure, right? Because here inductor is placed, and again is asking VA of 0 plus, but the procedure is same. Step 1. T equal to 0 minus equivalent. So how does that network look like? See, over a period of time, you must be able to solve the network directly on this without drawing the network. I'm telling you, in exam, you don't have much time. You need to save the time to the possible extent. But in solving the, in saving the time, okay, you are not supposed to do mistakes. I'm telling you, okay. Your answer is very important ultimately. So if you are able to practice without solving the, without redrawing the network, okay, that will be good. I'm telling you. Open circuit. This is acting like a short circuit, but physical inductor is available. 10, 20, 10, 10, 5 volts. What is your objective in the first step always? Current through inductor, voltage across capacitor. Yes or no? So let me find current through inductor. Because it's 0 minus, okay? So for that, you definitely need, I think you can see, this is open, you can't expect any current. These two are the parallel paths, yes or no? 10, 20 parallel to what? 10. So, and this voltage is appearing across, now across 30, okay? And also across 10. So the current flowing here is what? 5 by 10 amperes, and here it is 5 by 30 amperes. Yes or no? So what is now IL of 0 plus? It is 5 by 10 plus 5 by 30. So what do you get? 3 5 are 15 plus 5 by 30. It is 20 by 30, and finally 2 by 3 amperes. Okay, and this information will help you now to construct T equal to 0 plus equivalent, step 2. Why I am going for step 2, you might have understood by this time, because I am dealing with what? Voltage. Voltage, what? It's not voltage across capacitor. It is other than voltage across capacitor. Definitely I have to go for step 2. That is T equal to 0 plus equivalent I am supposed to construct. What is that? You have inductor. Inductor is replaced by what? An equivalent current source with a parallel inductor model. Yes or no? This is 2 by 3 ampere. This is an inductor physically available. There is an equivalent model. Okay. 10, 10, sorry, 20. This is 10. This is also 10. Now this is 5 volts. So what is your objective here? To find the voltage at this node, that is VA of 0 plus. What is that? VA of 0 plus. Okay. VA of 0 plus. Now, just look at this, all of you. How do you solve it? To find the voltage at this node, look at this. There is another node where we need to create a variable. Yes or no? Here the variable is not required because it is already known value. It is 0, therefore it is 5 volts. So there are 3 nodes. You need to create one more variable. What is this value? Let us say VB of 0 plus, because already VA of 0 plus is there. Let me, okay, call it as VB of 0 plus. Now definitely you need to solve 2 equations. Understand, all of you? Okay. So let us see what will happen here. Let me use inspection 1 by 10 plus 1 by 20 plus 1 by 10. Yes or no? Inspection means 1 by 10, 1 by 20, 1 by 10. What is this particular one? The elements related to B, 1 by 10 and 1 by 20. 1 by 10 plus 1 by 20. What about the common element between A and B? Minus 1 by 20. You know that off-diagonal symmetry we already learnt in the beginning class. Node analysis of mesh analysis. Okay, we have learnt already these things. So don't expect a detailed explanation here. Now, at node A, okay, 5 by 10 I can write. For node B, 5 by 10, same time the current source is there. So 5 by 10. What is the current source doing? Leaving or entering? Leaving. Therefore minus 2 by 3. Understand, all of you? Okay. Now your requirement is what? VA of 0 plus. Apply Cramer's rule. Delta 1 by delta. Okay. So please solve this. Delta value is nothing but what? The determinant of this particular one. Delta 1 is replace this by, okay, this particular column and then find determinant. Then finally you get the answer. I'll give you directly the answer here. Okay. 1.904. Please cross check this using your calculator. 1.904 volts. Okay. So this is how you need to solve the problems. Okay. Look at. Note down that quickly. Cramer's rule we can apply for more than one equation. Better you go for Cramer's rule. It is easy to apply. Note down. Then meanwhile I just go with question number 9. Find A. I of 0 plus, V of 0 plus. P. D I of 0 plus by dt. dV of 0 plus by dt. Okay. What is the network given? Okay, 1 by 20 farad. This is V. This is 2 ohm. Here is an inductor. The voltage source, 24 volts. I. Okay. So let us solve it. I think all of you finished that part. The previous problem you have finished, right? Okay, let me take this off. Let me take this off. Okay. Okay, I think you understand what is I, what is V. What is I? I is current inductor. What is V? V is the voltage across capacitor. This observation is very important. Whether that I is current through inductor or other than current through inductor, whether that V is voltage across capacitor or other than voltage across capacitor, if you are able to catch that point in the first instant or first glance itself, I'm sure that you can get the solution easily using our step-by-step approach. Okay, so let us look at step 1. What is step 1? Tell me all of you, what is step 1? Construct T equal to 0 minus equivalent. What is he asking? I of 0 plus V of 0 plus di of 0 plus by dt dV of 0 plus by dt. Okay. First order derivative terms, even though they are first order, but I is current through inductor, V is the voltage across capacitor. So our job is very simple now. Go to step 2 and then solve it easily. Don't need to go for step 3 here. Okay. So T equal to 0 minus equivalent. Switch is open, right? Inductor is acting like what? Short. Capacitor is acting like open. Then 10 and 2 are in series. Then you can find directly. Now I am not going to draw the equivalent. You please draw the equivalent. I have shown so many examples. Please draw the equivalent circuit on your own. I'm just going to explain. This is a short circuit. This is an open circuit. Okay. If it is unavoidable, I will just definitely draw it if there is any complexity involved. So I of 0 minus is 24 by 10 plus 2, 12. 10 plus 2, 12. Therefore, it is 2 amperes. Then what is V of 0 minus? The same 2 amperes is flowing up to this. This is a voltage across 2 ohm. Therefore, 2 into 2, that is 4 volts. Or else you can say 2 by 2 plus 10 into 24. The same answer you get. Okay. Then finally, you got actually here I of 0 plus is nothing but I of 0 plus is nothing but I of 0 minus 12 amperes. V of 0 plus is equal to V of 0 minus is 4 volts. Step 2. Why I need to go for step 2? It is only for the sake of question number B. For A, you don't require, because directly he is asking current through inductor and voltage across capacitor. Step 1 itself you will get the answer. But I am going for step 2 for the sake of the first order derivative terms. Because di of 0 plus by dt is nothing but VL of 0 plus by L. Okay. So now let us go for step 2, t equal to 0 plus. dV of 0 plus by dt is nothing but IC of 0 plus by C. Okay. So I need to find VL of 0 plus and IC of 0 plus. For that, let me draw the equivalent circuit. For this, I am drawing the equivalent circuit. Switch is closed. Okay. Once it is closed, then it is shorted. Can I neglect 10 ohm resistor here? Agree all of you? I can neglect 10 ohm resistor. Inductor is replaced by what? A current source with a parallel inductor model with the value of 2 amperes. Capacitor is replaced by what? A voltage source, okay, with the value of 4 volts with a series capacitor model. Finally, the network looks like this. This is the capacitor. This is gone, okay, shorted. And now this is what a current source with a parallel inductor model, and finally you got the voltage source. I think all of you understand this. This is 24 volt and this is 2 ampere. Yes or no? You already got 2 ampere, and this is 4 volt and this is 2 ohm. Okay, and here is an inductor. Since the direction of current will decide the polarity is plus minus, therefore here it is plus minus VL of 0 plus. Since the polarities will decide the direction of current to the capacitor, passive convention plus minus, therefore current flows from higher potential to lower potential downward. Therefore this is nothing but IC of 0 plus. Okay, for current, direction is important. For voltage, polarities are important. Okay, now tell me here, look at this, all of you. The current can be determined here. Look at this. Current through any path. When there is no resistor, you are supposed to apply Kirchhoff's current law, yes or no? So what is the current actually? 2 amperes. What is the current here? The same voltage will appear. Actually the current flowing here is 4 divided by 2, 2 amperes. And 2 amperes is entering, 2 amperes is leaving. Therefore, this current will become 2 minus 2, 0 ampere. Now this voltage will become potential difference between 2 points anywhere in the circuit. I can go with the touching concept, nothing but KVL only. Now plus to minus, I'm touching positive first, therefore plus 24. Okay, and I'm touching negative first. Can I come like this? Come like this? Yes or no? Okay, touching plus and touching minus. So minus 4. So this is plus 20 volts. Understand all of you? Okay, agree all of you? So once you get this value, substitute there, what will you get? Tell me. This is 20 divided by L value how much? 0.4. 0.4. Okay, L value 0.4. You can 5, and then you get this is 200, and finally, okay, for 5 50 amperes per second, and this is 0. Okay, 0 volts per second. That's it. Okay, so please note down. It's very important problem. 50 amperes per second. Note down. Meanwhile, I just take this problem. Okay, you can note down the solution. I just note down another problem here. Meanwhile, question number 10. Please note that solution. I will give another problem here. Question number 10. Find IL of 0 plus, VC of 0 plus, d IL of 0 plus by dt, d VC of 0 plus by dt. Okay, the network is given something like this. One by 2 farad, 4 ohm, 2 ohm plus minus VR, 3 U of t, 20 volt. Okay. So that's the problem given. And let us now look at the solution. Let us now look at the solution. I think you have done with this, right? Okay. Now, just let me take this off. Okay. So read that question carefully here and observe the network. What is actually is asking? Look at this. He is asking IL of 0 plus, VC of 0 plus, current through inductor, voltage across capacitor. Even similarly the derivative terms. So obviously from first step itself these two can be calculated, and from second step these two can be calculated. Okay. But of course first step is mandatory. So step 1, construct T equal to 0 minus equivalent. Okay. But here the switching operation is not given. Understand? Switching operation is not given. Sometimes he doesn't give switching operation, he will give the step function. What do you mean by step? Step is nothing but what actually here? Step. What is step actually here? Step is nothing but what? U of t. This is t. This is 1. So you can define unit step function value, that is 0 for t less than 0 and 1 for t greater than or equal to 0. Yes or no, all of you? Okay. So what does it mean? It's nothing but switching only, right? Okay. You're operating the switch. Step function, resembles, or it will do the function of what the switching operation is doing. Okay. The same thing can be done by the step function. Okay. Therefore, you can now construct t equal to 0 minus. You can now construct here the equivalent. For t equal to 0 minus, this value is what? 0. Yes or no, all of you? For t equal to 0 minus, this value is 0. Current source value is 0. That means what? Open circuit. That means what? Current source value is 0 means open circuit. Now resistor remain resistor, and resistor, capacitor is acting like open circuit. This is plus minus. Now what about this? This is short circuit. Understand all of you? Okay. Now what is IL of 0 minus? IL of 0 minus is what? 0, because there is no source at all. It is isolated completely. This is also isolated, therefore 0. What about VC of 0 minus? VC of 0 minus is the voltage which is appearing across the voltage source, right? So therefore 20 volts. I can say VC of 0 minus is minus 20 volts. I hope you understand why I'm taking minus, because this plus is connected to minus and minus is connected to plus. Now from this we can conclude that IL of 0 plus is equal to IL of 0 minus, nothing but 0. VC of 0 plus is equal to VC of 0 minus, nothing but what? Minus 20 volts. That's it. Okay. That's it. Now to find the dIL of 0 plus by dt and dVC of 0 plus by dt, let us construct t equal to 0 plus equivalent. At t equal to 0 plus, here at t equal to 0 minus u of t value is how much? For this 0. 0 amperes, nothing but open circuit. Okay, here u of t is 1. Okay, therefore the current source value is how much? I will become 3 amperes. Okay, therefore it looks like this now, 3 amperes. And now resistor remain resistor, yes or no? And resistor remain resistor. Now this capacitor will be acting like what? A voltage source. Okay. And current source, the inductor is acting like what? 0 ampere. That means that it is open circuit. and physical inductor is available, you require VL of 0 plus here, and you require IC of 0 plus here. Yes or no, all of you? And this is minus 20 volt. This is already 20 volts. Minus 20 volts plus 20 volts, addition 0. That means the entire path is acting like a short circuit. And this is 4 ohm. Yes or no? And this is 2 ohm. And this is already 3 ampere. Because 3 u of t, right? Therefore, I think you understand this, right? So therefore, now you can see that VL of 0 plus will be definitely what? 0. Because this is the addition of these two will become 0, the total voltage will become 0 volt. But the current passing through this path is nothing but what? Since it is open, the entire current passing through 4 ohm, nothing but IC of 0 plus. Therefore, IC of 0 plus can be taken as, because these two are now in parallel, now current will be divided 2 by 2 plus 4 into 3. Now 3 2 ja, and finally, okay, 2 2 ja, so 1 ampere. Okay, finally you got 1 ampere. And finally here, the d IL of 0 plus by dt is nothing but VL of 0 plus by VL of 0 plus by L, nothing but 0 amperes per second. And d VC of 0 plus by dt is nothing but IC of 0 plus by C, nothing but what? 1 by, what is the capacitance value? 1 by 2, nothing but 2 volts per second. This is how you are supposed to solve the problems. Hope I think all of you understand. Note down the problem clearly. Okay, so we stop the session here and we can discuss remaining problems in the next class. We have so many problems to discuss.